In today's video, we're going to be setting up the Cube ID remote ID solution in the ArduPilot ecosystem. So the Cube ID is a little circuit board essentially that's going to attach to the CAN bus on the ArduPilot. And what it does is it complies with the FAA's remote ID requirements in that it'll broadcast your drone's kind of identifying information, such as your FAA registration number and information about the operator and the type of drone and so forth. And it'll broadcast information about where it took off and its current position. So what that does is essentially it allows you to use an app like Drone Scanner to see what drones are operating in the area, who's controlling them, and so forth. Now this device, let me pull it out of the bag here. It's a little circuit board. I bought this from IR Lock, and it comes with a CAN cable, a little board with an antenna mount on it, and then it also has an antenna whip that'll screw on the top here. So basically, we're going to mount this into the drone, connect it to the CAN port, do some configuration in ArduPilot, and hopefully we'll see our drone's information broadcasting when we pull up the app Drone Scanner on the cell phone. So this thing broadcasts over Wi-Fi and Bluetooth, so it should be fully compliant with the FAA's current regulations on complying with remote ID requirements. And so we'll hook it up and see how it all works. So let's head on over to the bench and get started. So here's the package that I received for this Cube ID device that we're going to hook up, and there's not much to it. It came with these components in there, which is the Cube ID module itself, an antenna, a CAN cable, and then this one is labeled Cube ID to GHR6. Not quite sure what I'll use that for yet. It's important to note that I bought the drone CAN version of the Cube ID. There's actually two different versions that you can buy, and this one specifically is the drone CAN version. What I really like about this CAN setup is it's super easy to interface new devices onto your drone. You know, where typically in the past you would get stuck by having only a certain number of serial ports and each device having to be wired up correctly. The CAN interface is a nice standard in that since it's a bus, you can hook up as many devices as you want to it for the most part within the physical limits of the electrical circuitry and the data transmitted across it. But if you remember in prior videos, for my CAN setup specifically here, I've got the Holybro CAN hub connected to my core carrier board, and then off of that Holybro CAN hub I've got two of these extension boards down here. So watch the prior videos. I actually set all this up before we mounted the motors and this wiring mess occurred. So in this, my motors all speak CAN. I got 6 motors attached in here, and my Here 4 GPS is also attached to this CAN splitter down here. And so what we're going to do for this CAN, or for this Cube ID solution, is I'm just going to use the CAN cable, the Cube ID, and the antenna whip itself, and we're going to put it together and connect it. So first thing I'm going to do is I'm going to take this antenna whip, and it's just looks like a standard kind of coax connector. We're going to screw that on. Okay. And then on the other end is where your CAN cable is going to plug in. So these are just standard JST-GH connectors, 4-pin. And it comes with a wire that's already nice. It's got the twisted pairs on the CAN low and high signal wires. And all that's left to do is if you've got your CAN splitter already connected to your ArduPilot, if you're using a core carrier board, it has a CAN port. If you're using the carrier board that comes by default with the Cube, it's a little rectangular looking box, it also has a CAN port. So you can use a CAN splitter and split that port out into multiple ports, or you can plug just a single device into the CAN port right on your carrier board if needed. But anyway, in my scenario, that's all that's needed, right? So this drone CAN type of approach makes things super nice. It's real quick and easy once you get your base infrastructure set up to add new devices. So I'm going to set this thing maybe right here in the middle. This is my just kind of prototype experimenting board that I got set up here so I can test all the electronics before I actually install them in the drone itself. I'm going to have to figure out when I install the electronics in the drone, how I'm going to run the cables. I'm going to have to make some better, higher quality cables with better connections. Figure out how to mount all this efficiently in the drone so that it takes the least amount of space and isn't a rat's nest of wiring and so forth. So anyway, here's the Cube ID just sitting here. And we can go ahead and power it on. I don't think there's any indicator lights on this thing. No, it doesn't look like it. So it just kind of sits there and will broadcast your remote ID information over Wi-Fi and Bluetooth. So next step is we have to go over to the computer. We need to configure the ArduPilot settings to tell it that this device exists. And then we can plug in the remote ID information into the ArduPilot interface, and it should broadcast, and we should be able to see it in an app such as Drone Scanner that you can install on your computer. So I'm going to pause the video here, go over to the computer, fire up ArduPilot, and we'll start to configure the software side of things over there. All right, so for setting the appropriate parameters to enable remote ID on your drone, you are going to have to build a custom firmware for ArduPilot and install it on your Cube. So what I want to walk you through is some of the documentation I've compiled that shows you how to do that. From the main wiki page for this project, which is linked to in the YouTube video below, we're going to click and go to the wiki documentation and home folder. And if you scroll down, we're on part 8 of this video, and this Cube ID link will take you to the information related to setting up this remote ID unit. I tell you right here on the notes that you must build and install a custom ArduPilot firmware in order for the DID config parameters to be available. So let's drop to the ArduPilot configuration page that I have in here. And I walk you through how to build that custom firmware as the very first thing, right? So if you're setting up a new Cube from scratch, first thing you do is go build your custom firmware, load the built binary file onto the Cube, and then go ahead and set your parameters. If I scroll down here, these are all the parameters we've been collecting through the previous videos that need to get configured and set on your ArduPilot parameter list. Down towards the bottom here, there's a parameters section for the Cube ID. And you can see these parameters all start with DID. So I think it stands for Open Drone ID. DID enable you set to 1 first, and then you'll be able to set the DID CAN driver and the DID options. If I go into Mission Planner and I drop to I'm connected to it right now. I just have it plugged into a USB cable. I don't have the battery connected or anything to my Cube Pilot. When I go to config and the full parameter list, if I search for DID underscore, you'll see nothing comes up in the list. There are no parameters, so I can't even set that DID enable setting at all yet. So what we need to do then is follow along with these instructions at the top for building your custom firmware. Now I went round and round reading documentation. I was like, come on, do I really have to build a custom firmware? And yes, it appears that is the only option. The good news is ArduPilot makes it super easy. So if you follow these instructions here I have in the ArduPilot config, it'll only take you a couple minutes. So step one is we're going to go to this custom ardupilot.org website. Let me open it in a new tab so we can bounce back and forth. And it takes you through this page showing all the most recent builds and so forth. Let me stack these pages side by side so we can see them both at once. And all you need to do is we're going to press the Add a Build button. So I'll go ahead and press that. For the vehicle type in this dropdown, we're going to select Copter. For the branch, rather than latest, I'm just going to say Copter 4.5 stable because that is the latest version of the firmware that I am working with. And for the board, because I'm using the Cube Orange Plus, I'm going to go find that down here and select Cube Orange Plus. Now, I'm not going to pretend to know what all these different parameters and settings are yet. I'm hoping that this is all out of the box configuration. I imagine you could probably make your firmware more efficient by turning off features that you know you're not using and needing to spend compute power on, but that's for a future learning for myself to get to know more about it. What I do know is in your custom firmware, you want to go to the ident category, and we're going to expand that out, and we want to check this Open Drone ID box here. Once you do that, we're going to go ahead and press the Generate Build button at the bottom, and that's going to open up this pop-up window where it will go ahead and create a build. So it's taking a minute. It's got to wait for an open build server to be able to compile and create the binary file. You can see mine is in this pending state here. There was one running previously to me, so we got to wait for that to get done. It does give you kind of a summary of all the settings that were set that it's going to do the build on. And so you just wait for this to finish, and then you'll be able to access your binary file and load it on your flight controller. So I'm going to close that for right now. You can see here is my build here. Here's the hash. Over here, you can pop open that log window that we were looking at. And you can also open the build directory, which is where you're going to get your download file when it's done. So that is where you'll have an ArduCopter.apj file that will show up in this directory that will download and install when done. Okay, so ours is running now. Oops. If I open the log, we should start to see some output. There we go. So you can see it's compiling. We have these new log messages up there of the steps that it's running. It's running compilation tasks now. 236 of 1174 is our current step. 359. So you can see it's going quite fast, and it's just refreshing this window here as it shows the progress. All right, build finished. So there we go. So now if we open the build directory, you'll see you have your ArduCopter.apj file. What we're going to do is just download that, and then we will be able to install it on our cube. So in order to install, we're going to go to the mission planner, these last few steps here, set up, install firmware. We're going to load the custom firmware, and we're going to select the APJ file and flash it to the board. So I'm going to close this web browser since we downloaded it. We're going to go to mission planner. And in order to install firmware, you have to disconnect from Mavlink, right? So because I'm connected so I can look at the parameters, it won't let me load firmwares. So I'm going to go ahead and disconnect there. And now we're going to go to the Setup tab, Install Firmware. I'm going to select the Copter. Actually, I'm going to say Load Custom Firmware. And it's going to show me the firmwares that I downloaded. So this is one I did earlier this month. This is what your file name will actually be. The one with the parentheses, one after it is because I just did the one today, just now, and downloaded. And so that's what that one is named. So I select it and say OK. And it's going to connect to the cube and remove the old firmware and install the new. You'll see a little status message down here in what it's doing. It was previously erasing the firmware. Now it's programming it. And that's it. Upload done. You can hear the chime with the Cube Pilot just rebooted itself. And so now we should be able to connect and see those parameters. So I'm going to go to our Data tab. I'm going to say Connect. And if I go to Config and our full parameter list, if I search for DID underscore, you'll now see there's a DID enable option. So if we go back to our wiki page for video number 8 here for the Cube ID, we've just done the step for installing a custom firmware. What you need to do then is set these DID options that we have in the ArduPilot configuration page, right? So again, this is the page we're looking at with the detailed steps and all the information on settings that we do to the flight controller. We did this custom firmware section. I'm scrolling down now to the DID settings for the Cube ID. And so DID enable, we want to set that to a 1. Let me stack these side by side. So DID enable is going to become a 1. And I'm going to write that param. So you need that to be enabled so that you can then see your other parameters for DID CAN driver and DID options. So I'm going to refresh the params. And now I see DID CAN driver and DID options. Now for DID CAN driver, that'll be default to 0. Change that to 1, which will be driver 1. It's the drone CAN driver index. And remember, for this video, I am using the drone CAN version of the Cube ID. So if you, for some reason, bought the serial version, you'll have to use some different settings that I'm not accounting for here. I like the CAN version. It makes this stuff so easy to configure and utilize. The other thing that we're going to do is under DID options, if you click it's set to 0 right now, but if you click this set bit mask button in here, what I like to do is I'm going to check allow non-GPS position, and I'm going to check lock UAS ID on first basic ID. What those do is allow non-GPS position lets the open drone ID still proceed in ARM even if you don't have a GPS position for your copter. When I'm working here in my basement and testing, it gets really annoying. It will just keep spewing out a message saying ODID, lost operator location, because I don't have a good GPS fix in my basement. So that's, optional. You may want to turn that off when you're on your field to ensure that you do have a good GPS position when you are really flying and arming. If I back up to the page 8, right on the YouTube video for the Cube ID, I talk a little bit about remote ID down here, and ultimately at the end of the day, you do have to broadcast the current location of the model, latitude, longitude, and altitude, and the takeoff location. So a GPS position is required to be fully compliant, right? Checking this just lets you kind of do some benchtop prototyping without annoying messages. Enforce arming, I leave off, right? If you want to ensure that remote ID is working before you're allowed to arm, you can check that. And then this last one was very cryptic to me. I had to do some experimenting to figure it out. But in Mission Planner, you end up setting your UAS ID. And really what that is it's the field for the serial number of the remote ID module. Now, because this is a custom build, I don't have a manufacturer serial number. I'm just going to put in my FAA registration ID. I think that's the right thing to do. Ultimately, it allows you authorities to tie back that ID to some identity. What this setting does is, in Mission Planner, if you don't check this, you will have to type in your UAS ID every time you run the program and you fly, from what I can tell. If you check this, the first time your flight controller sees a UAS ID getting broadcast, it will write that to persistent storage on the flight controller. And so what that does is it saves it and it keeps it persistent so that next time you fly, your UAS ID at least will be stored and broadcast without having to type it in. It doesn't appear to store the other fields such as the operator ID and the operation description and things like that. But from what I can tell with the FAA, those are not required anyway to be broadcast, so you'll probably be okay. So I'm going to close this. Again, the setting gets set to a value of 6 when you have that bit mask set correctly, right? Allow non-GPS position and lock UAS ID. And remember, we set the DID CAN driver to 1. So we'll go ahead and write those parameters. There we go. And I'm going to go ahead and hit Control F to pop open this window and reboot the Pixhawk. That should make everything take effect. So what we'll do next is start to configure things in Mission Planner so that it is broadcasting the appropriate information, and we'll take a look at how this gets displayed in an app on your mobile phone, such as Drone Scanner. So I'm going to pause here, set up a couple things to film the next segment, and then we'll be moving forward. Okay, for this next step, I've powered on my workbench board with the Cube Orange and our Cube ID set up and installed on it. And I've got this sitting outside so that we can get a good GPS fix and see that things work. I've also went ahead and set up the GPS antenna for the ground station. So I got this, and this is sitting outside. Got a cable running all the way to my basement. So I'm going to go down there right now and connect everything up to Mission Planner, and we'll start to see this remote ID solution in action. In my connections on the inside of the house, I got my Here 4 base unit connected with the coax cable running all the way outside. Here link controller set up. I got a phone next to me ready to use drone scanner, and I have Mission Planner up and running on my computer and connected to the Wi-Fi access point on the Here link controller. So you'll need to set all that up and get things connected so everything is talking to be able to do the next steps. In Mission Planner, I am connected to the HereLink Wi-Fi network, the access point that is set up on my HereLink controller, and this is Mission Planner running on my ground control station, essentially the laptop that I'll take to the field with me. Now, what we're going to be looking for in the bottom corner here is a tab called Drone ID. It may not be displayed by default on your Mission Planner. I also updated to the latest Mission Planner beta version, which I just posted a little video on. It only takes a couple seconds to do, but essentially you're going to go help, and you're going to go check for beta updates, and it will get you on the latest and greatest beta version. So if you don't have a Drone ID tab down here, you're going to right click on these tabs and say Customize, and you're going to check the box next to Tab Drone ID. That will make it show up. Okay. Now, there's essentially 3 tabs down here: Status, UAS ID, and Operations. In the UAS ID, you want to put in your FAA registration number. So if I type in the FA3EH and the rest of the values here, and under UAS ID type, at least in the United States, we're supposed to broadcast a serial number that I understand. CAA Registration Authority, I think, stands for Civil Aviation Authority, and that's a UK-based thing. So I'm going to pick serial number, and in the UA type, I picked helicopter or multi-rotor. Right? There's a bunch of options in here, but this fits my use case because I'm making a hexacopter. Okay. The other thing you can set in the Operations tab is your operator information. Now, this is required in the UK from the reading that I've done, not quite required yet in the US from what I understand. Now, your operator ID, if you're in the United States, you can make it something descriptive. You can make it your FAA registration ID. You can make it your name. Right? And CAA is the only option in this drop down here. The self-ID description I'll show you in Drone Scanner on the mobile phone will actually show up in an operation description. So, we can call this Cube ID testing. And I'll show you where that shows up. Now, there's one very important thing. Before you go ahead and set all these values, this UAS ID, if you set it, and in the previous section of this video, I recommended that you set a parameter for the DID options. If you have this lock UAS ID on first basic ID received checked, the first time your ArduPilot sees that UAS ID, that serial number, it's going to write it into persistent storage on that ArduPilot, on the Cube Orange, and not let you change it ever again. I've got an open post to the ArduPilot discussion forums to figure out how I can change that, but I can't find a way. I've tried wiping the firmware. I've tried changing to rover firmware and then back to copter. I've tried changing to PX4 firmware, and it won't let it do it. So if you're just testing, go back to your DID options before you set that serial number and uncheck lock UAS ID. Now, one of the problems with Mission Planner here is it doesn't seem to remember these parameters. So if you don't have lock UASID checked, every time you open up Mission Planner, you're going to have to retype in your UASID here. If you did check it and it saved it to persistent storage, it will load automatically, and it won't show in the display down here, but it will broadcast. The Operations tab is always starting off blank every time you open Mission Planner, and you have to reset that stuff. Would be kind of nice if there was a save feature to load this on the ground control station. Okay, so another thing to show you too, in the config section, actually setup section, I believe, I do have my ground control station connected to my Here4 base station. So it's got an RTK GPS setup, and I've already connected that. You can see my Here4 GPS setup video if you want to understand how I set all this up. But it does have a location for the ground control station. And if we jump over to the data tab, you can see I got a GPS of RTK float. So it's using the RTK capabilities. On the config tab, if I go to mavftp, remember I was talking about that persistent parameter for my UASID? If you go to mavftp and you click on your sys file system here, you'll see a file in here called persistent.parm. If you download that, let me just stick it in a folder down here. We can actually go look at that file. Oops, let's see if we can find it. Open Notepad++. And actually, I got the file already opened here. So inside of that file, you'll see the values that you set on your UASID tab. So it starts off with this persistent start v1, your open drone ID, UASID, the type, the ID type, which correlates the serial number for me, and the UA type, which is the multi-rotor option we selected. If you edit this and re-upload it, try to delete it, do anything like that, it won't let you. I've tried a bunch of things trying to blow these values away, and I just can't get them off the flight controller. So be aware, once you set that bit and you set your UASID and you tell the ArduPilot settings to lock that ID, I can't find a way to change it yet. So even if I try and delete this file entirely, permission denied error. Okay. So what else? We should be able to go over and look at the flight controller and drone scanner on a mobile app now, and you can see the information that's getting broadcast. If you disconnect your ground control station, you'll get an error message that just gets repeated over and over on the HereLink controller. I would love a way to disable that if possible, but it shows up down here, this ODID, lost operator location. It will just repeat that every 5 seconds or so, which gets kind of annoying. So just be aware of that. If it's repeating that, it means your ground control station isn't connected. So, all right, I'm going to go over to try and film my phone now and show you what drone scanner looks like. And you can see how this all comes together. All right, over on my mobile phone, I have an Android phone, and I'm in the Google Play Store here. There's an app in there called Drone Scanner, and I've already installed it, so I'm going to go ahead and hit open. And what that does is it will start scanning for drones here at the bottom, and it will start to pick up anything that's broadcasting on the Bluetooth or Wi-Fi frequencies. So you can see in here, it only updates every so often, every 10 seconds or so. But down here you can see it identified my FAA number, it identified the operator description that we plugged in. And if I touch on it, you get some details, but I can swipe up. We'll be able to see this is picking it up from the Bluetooth legacy, the MAC address of my cube, when it saw it, There's the serial number displaying there. That type that we set, hexacopter or multi-rotor, or helicopter or multi-rotor. And then you can see that operation description was that description that I set back in Mission Planner. Status is grounded because it's not running right now. And its current location, that's the GPS from the drone itself. Location, altitude settings, all that stuff is required to be broadcast by the FAA. And then down here under operator, you can see the operator ID, but there is no operator location, and I can't figure out for the life of me why that is not getting broadcast. I've tried to arm the drone and see if it would pick up the GPS coordinates as the takeoff location. I just can't get that to show up. So if anybody has any tips on how to get Mission Planner and ArduPilot and this Cube ID to broadcast the operator location, that would be helpful if you could let me know. So that's basically it then. You can see my drone scanner is now showing 2 drones. It's picking them up on both the Bluetooth Legacy, and then there's the Bluetooth 5, and it can also pick up a Wi-Fi signal too. It doesn't look like it's reaching down to me in my basement though, where I'm filming this. But it broadcasts the same information. You can actually tag the serial number and MAC address is yours and enter a label for it. So it'll always show up in Mission Planner that way. If I set it as mine, whoops, can't do it without a manufacturer code. So I don't know where to set manufacturer code and model in Mission Planner. So again, if anybody has tips on how to do that, that would be useful as well. Now if I go ahead and arm this, you should see the status of this change in a second here. Assuming it refreshes fast enough. Let me back up one. Well, it was updating earlier and it was showing that it was not grounded. May need to run it a little bit longer. There you go. So it's showing right there, that blue signal. Its altitude and the ID and stuff. A little hard to read, but it is showing that it's going. So this is what I've been able to figure out so far on how to get this running and bind everything together and make this Cube ID work. If you have any helpful tips on things I did wrong or setup that I missed, please let me know. The documentation seems pretty sparse on all this, on how it all binds together. It appears to be an evolving area, at least in the US, on how to make this remote ID capability work. But this is as far as I've got so far. So thanks for watching. Tune in the next video.